fellas that look like that. Super heavy weights.
We see like the weed. It's fun.
450.
Mm-hmm.
He'll get a kick out.
He's in Florida.
Yeah, he's Disney World Brady.
Doing busy around.
Trying to pick up single women.
Yeah, he just went.
I don't think single was part of
Or no, the day before.
Yeah, and women wasn't. Yeah, women wasn't exactly part of the
He's like,
Then
he leave Friday.
Saturday.
He left Saturday. If you go see, you can see people.
Check it out.
No, his stepbrother has been like posting every day
All right.
what they're doing.
Yep.
Watch.
They're
They're funny as crap. Get a video. His whole family on his stepdad.
Make sure they get out.
Jason.
You got it? Close minimize that?
Okay.
Working?
Yeah.
Awesome.
Start this pretty soon.
Yeah, we're gonna start it right now. We just got it fixed. We had a problem on the transmission, but we're good to go now.
Okay.
All right. we're good. Yep, we are. Just give it 1 more minute so we can notify the guys over there in Omaha that they're waiting as well, and the Ericsson team that is logging in.
Cool.
And okay. All right, you guys say that they're on. So.
Ready?
Yep.
All right. Without any further ado, I'm Corey with FES. I've been here 11 years. I currently work as a project engineer. We're going to cover a little bit of introduction to HVAC, a little bit of controls today. Here we go. What does HVAC stand for? You all know this. We work in this industry. Should be pretty straightforward. Heating, ventilation, and air conditioning. You all seen it, you all know it. Pretty easy. Now, what is the primary purpose of the HVAC system? You all know? I was 100% sure when I looked into it, but here's what we do. Primary purpose is maintaining a proper building environment. It's not about cooling, it's not about heating, it's maintaining a proper environment for people to work and live in. What makes up the building environment? Does anybody know?
Temperature, humidity, pressure, ventilation.
Temperature, humidity, pressure, and ventilation. Yes. Now the temperature depends partially on the room, partially on the location, and partially on cultural norms. It's going to be cooler here in the United States than it's going to be somewhere in South America, Middle East, other countries that they don't have the same requirements, same abilities that we have here in the United States. As far as humidity, same deal applies. But as a norm, at least here in the States, it's 30 to 60%. It's normal building environment, your home, at work. Some rooms are different, just like everywhere else. Things are always out of norm. Pressure, rooms are normally positive, but here we deal with a lot of medical places and a lot of sometimes medicine, so rooms can be negative as well as positive in an anti-room situation where it's negative to one space, positive to another. Now, as far as ventilation, I would put pressure and ventilation close together because you can't ventilate without altering pressure in a space, because you have to add more air into a space to pressurize it or remove more air than you can make. How do we perform this? Basic cooling in a building. That is through the refrigeration cycle. Now, this one for us personally is not a standard refrigeration cycle because the refrigeration cycle applies specifically to refrigeration, but it still applies to what we do in cooling a building. So there's two main parts. You have your evaporator. Oh. You have your evaporator, and then you have your condenser. Your evaporator is going to add heat to the medium, and your condenser is going to remove heat from the medium. Does anybody know why in cooling we call it removing heat and not adding cooling?
Because you can't cool air.
You cannot cool air. You can only remove heat from a place that it's not wanted to a place that it doesn't make much of a difference. And that's typically from inside your space to outside. Now, we do this many ways, and we'll cover that going forward. Now, does that go in?
No, move it off.
No, I gotta do that. Go away. Oh! Is there back?
Yeah, on the other side there should be a...
Oh no.
You're making it worse.
Now, in heating, we are adding heat. And heating is very similar property. You're going to add heat with a heating element, and then you're going to remove heat through the heated area. So it's a similar process, just in reverse. You're taking heat from one place, putting it in another. Now, humidity in a building. It's pretty important because we all like to be comfortable. We don't want to be too hot, feeling sticky. We don't want to be too dry, or drying out, skin drying out. Matt knows all about skin drying out. Humidity in a building. We have humidifiers to add humidity, dehumidifiers to remove humidity. Pretty self-explanatory. But you can also add humidity to a space based on outside air. It's going to be your wet bulb. Humid enough outside, you can pull in more outside air to try to add some humidity to your space if you're low in humidity. As well as heating and cooling. Naturally, through heating and cooling process, you will add cooling a little bit. You're going to add low humidity. And in heating, you're going to take out a little bit of humidity. And this is a standard kind of representation of how we show it on control drawings. It's pretty simple, pretty straightforward. Now, does anybody know why we have a high limit and a flow switch? Mike?
So it doesn't rain in the duct.
Doesn't rain. What happens if it rains in the duct?
Makes a mess.
You have potential for mold, as well as water damage through the duct where it can leak out into your space, and then we have a much bigger issue than a little bit too humid of air.
Back charges.
Back charges. We never want those, that's for sure. All right. Pressure and ventilation. This one's another one. Pretty simple, pretty straightforward. You know, supply fan, which is going to supply your air to the space. You got a return fan that's going to return air back to your supply fan. You also have exhaust air, which is going to remove air from your building to the outside. How else we can gain air into a space is your air gain loss, and that can be air escaping a room through walls, bricks, depending on your facility, doors, windows, anywhere that air can leave a building. It can also come in a building, so you also have to account for that in your construction as well. Oh no. Typical components in your HVAC system. You have your air handlers, which are your source for cooling, humidifying, everything else. You got cooling towers, which we'll get into here in a second, which are used to remove heat from your condenser water. We have chillers, which are used to chill your chilled water, as well as add heat to your condenser water. And then we have boilers. Boilers add heat and boil water. Then our secondary equipment, and this is going to be general for every system in an HVAC system. You have pumps, valves, dampers, exhaust fans. It's pretty standard equipment. What are some types of air handler units? We have VAVs, or constant CAVs, which are variable air volume or constant air volume. Does anybody know? Pretty simple. Variable air is going to cut back on the amount of air in a space. Constant volume, you turn it on, that's the air you're going to get. You can't get more, can't get less, once it's balanced. Rooftop units, which are similar to split systems, where you're going to have a unit on the roof. It's going to provide cooling or heating based on your needs. And those are becoming more common in our industry, as well as ductless split systems for spot cooling and just cooling in general. Split systems can also be VRF systems, which we're seeing more and more of as well, where every indoor box, which would be in your VAV system, now has refrigeration going to it. These systems are becoming more common, where historically they were less common because refrigeration systems can be difficult to balance versus a chilled water system, which is typically easier to use. And then your fan coil units, those would be similar to a VAV system where you're going to have a box in the air. It just provides its own fan power instead of having a major air handler providing all your air. Air handler parts. There's a lot of parts to an air handler. Lots and lots of parts. And this isn't even all. There's some that we listed. These typical found on every air handler that we provide, whether it's a package unit or whether we install all these ourselves. You got supply fans, we covered turn fans. And you're going to have your cooling coil, your heating coil, or element. Now we say heating coil or element because you can heat with hot water, you can heat with electric. Hot water is more common for big air handlers. We also are seeing in smaller air handlers and smaller places where they want to use more air handlers instead of the big ones that we used to see all the time. They're providing more air handlers that are smaller, and often you will see a heating element instead, which will be just electric heat to turn on and off. And this can be either staged electric heat, or it's going to have multiple stages that all bang on and off, or you can have CSR heat, which will provide a ranged heat. The element will heat up, similar to a toaster. Then, economizer dampers. Does anybody know what economizers do?
If it's cooler outside than in the space and you want to cool, basically an outside air damper will allow that air to come in.
Yep.
Cool space.
Correct. And then minimum outside air dampers. Do we know why we have these?
Ventilation.
Air changes.
Ventilation and air changes. Filters. Pretty simple. You got to filter your air when you're bringing in outside air or even return air, because you're going to suck up dirt and dust and all other manner of stuff. Variable frequency drives, VFDs. We see these everywhere now, where you can see them in home, residential air handlers, because everybody's about electrical cost savings. And then valves, pretty self-explanatory. You got to open and close valves. And then other components. You have a static pressure switch, static pressure sensors, temp sensors, smoke detectors. Does anybody know what the difference between a pressure switch and a pressure sensor is?
Binary versus analog.
What would we use a pressure switch for?
Filter status.